Hi everyone, so this video is going to go over how we process our motion capture data with the Vicon system software. So when we open it up here, we are going to start by importing a new trial. This would have already been recorded from a participant coming in the lab and doing an interaction with us based on a specific study. And so from this, we're going to choose an ROTC military cadet from an earlier study we used. And so once we pick a static image of them, we can kind of see how this shows the environment of our lab with the camera setups in the volume of the space. And then we run an initial pipeline to reconstruct the model of the participant. So they just stand, we take a static image so that we can ensure all of our reflective markers are being shown, and then this produces all of our joint segments. And so we're going to select a model template that brings in all the labels for the markers. And on this, we want to make sure that we select revert to uncalibrated, otherwise some of them will end up missing. And it's an easy step to forget, and then you kind of have to backtrack a little. And so we start to label our skeleton, and so the markers are labeled with anatomical abbreviations. And once you do this process enough times, it kind of gets very automatic. You can see it goes very fast in this video. It's always the same pattern, so it's a repetitive process. And we go through and label each segment. So there's some hard plate clusters on the thighs, and then we have each segment between the feet, the arms, the torso, and those all get labeled with the individual names of each marker. And so the way this is set up, we can kind of move around the model and circulate it in space, which makes it a little easier. I like to marker from the back, so I'm looking the same direction as the participant, so your left is their left. It makes it a little easier to kind of stay on track, and then you kind of shift the environment around so that no markers are hidden and you are able to see all of them as you are in the process of labeling. And they're standing in anatomical position with their arms slightly out to the sides, which allows us to see all those markers, especially on their elbows and the pelvis. It keeps them from being hidden if their arms are down and our cameras aren't able to see them. And so once this is complete, it kind of triangulates the points. And so from here, we can kind of tell it's more of a person-like shape. You can pick out arms, legs, a torso, and a pelvis from that. And then we're just going to go through and select a few frames since this is just a stationary trial. So we want ones where all of our markers are showing. Initially that one was kind of flickering back and forth, and we want to select some frames where they're all showing. And then once we determine just a few frames, we enter those in, and then we are able to go back through and run another pipeline in order to save that trial. So once we have that saved, we're going to go back to our list of collected data, and we can go ahead and choose a dynamic movement trial. And to start out, once we pull that up, we're going to go back and run it through a pipeline to reconstruct it so that we can see those markers. And so now we can see where the participant is in the environment. And so once we play it through, we're just going to select the specific frames that we want of the movement. There's no need to process extra time of them just standing before they begin to move or after they land. And so sometimes it takes a little bit of time to choose what trial is going to be best to use. And you can easily just reconstruct multiple trials to decide which one that you are going to use. So here we're just trying to get a good idea of when they start their movement, and we can go ahead and crop those frames down a little bit just to save us a little bit of time in processing, and it eliminates us wasting some more time filling in some gaps in the movement pattern. So we can go back through and repeat the process of labeling these markers. Exact same as on the static trial. Sometimes it takes moving around a few frames to get everything to show. And if you notice, a few of the markers are missing from the static trial. Anything that marks a joint we typically remove because it will fall off during data collection, and we can use our static trial and those calibration markers to look at the length of joints, how wide they are, and use those in a different way. It just prevents us from losing them when someone is moving around, jumping, running, etc. And so as soon as this is done, you can see that it kind of triangulates those points, highlights them a little more, and we see more of an individual. And as we play it back through and the person moves, we see a lot of those markers turn back to white and lose the label that we just attached to them. When arms cross over a marker or they get blocked from the cameras, they aren't recognized. We need two cameras to see each marker at all times in order for it to register. And so the next part of the process is we're going to go through the trial frame by frame and reselect any of those markers that have come unlabeled during any of this movement. We go back and assign them their name. It can be kind of a tedious process. A lot of this comes from knowing the movement that is occurring and knowing what's going to be blocked, so you can kind of anticipate it. And then just understanding the anatomy and markering sets so that you can quickly identify the markers, pick them out of the list, and know what you're looking for. It kind of helps speed up the whole process, especially if you're doing some really long data collections, long trials. It speeds it up a bit. And ideally, when we make these models, we can assign the colors. We like to do the right side is red, so it's easy to remember, especially when you're spinning the person around in the volume and the space and moving it around to see what's appearing and disappearing. You can kind of keep it straight by remembering that the right side is always red. So we skipped over a little bit of that gap filling. It kind of takes a long while. And so we go back through and we play through the frames, kind of make sure that we know that we got everything. And then once we kind of play through it, make sure all the markers are still there, we got them all filled, we're going to go move on back to the process of filling those gaps. So every time that marker comes unlabeled, it creates a gap in our system, and we have to go through and fill that. So with this process, those blue cones show us where the missing marker should be. And so we go through and there's a specific way to fill it. We ideally start with a spline fill. It gave us an error message there. So we moved on to a pattern fill. You have to assign a source marker or a reference marker, and it bases the one that's missing off of the one that you identify. And so for most of the important markers like the pelvis that we really don't want to lose and we want to know that those are accurate, we use a pattern fill. So it's basing that missing marker placement off the ones that are still there and still found during data collection, and it kind of can base that point off of the other markers that still remain. And so for a lot of this, we're going to keep using the pattern fill, and then you can just select all and it'll fill all those gaps that it shows for that specific marker. For some of them, if it lets us start with a spline fill, we go ahead and use that and do all, and that will fill those gaps, especially when there's not that many. And you kind of just want to double check. This comes back with knowing the markering sets and anatomy, that blue set of cones is showing that marker in roughly the appropriate place. Sometimes it likes to skew them and send them in weird directions. You just kind of want to double check that you're putting that marker right back where it should be. And so when we use this spline fill there, it gave us an error message. And so it wouldn't fill the remaining gaps. So you go back in, you can choose a reference marker on that pattern fill option, and then it will be able to fill all those gaps that are remaining.